What if you could learn data science, AI, cybersecurity, cloud computing, digital marketing, and even project management completely free? No fees, no catch. And yes, you get a certificate too. Welcome to OMNI Academy, Pakistan's leading IT training institute since 2010, part of MHSG Consulting Group, helping thousands build real-world skills and land jobs. Every month, OMNI Academy offers 50+ free workshops taught by industry experts covering everything from AI and cloud to cybersecurity, networking, and more. Whether you're a student, a professional, or just starting out, there's something for you. Join online from anywhere in Pakistan, Karachi, Lahore, Islamabad, or beyond. So don't wait. Register now at omniacademy.com and secure your spot today. Omni Academy, your career transformation starts here and it starts free.
Welcome to our free Data Analyst workshop, where we are going to explore 3 of the most useful tools used in modern data analysis: Microsoft Excel, SQL, and Power BI. If you have ever wondered how companies turn thousands of rows of raw information into useful reports, business insights, dashboards, and decisions, this workshop is for you. Every organization generates data. Sales teams generate customer and revenue data. HR departments generate employee data. Marketing teams generate campaign and customer engagement data. Banks generate transaction data. E-commerce businesses generate orders, products, customer, and payment data. But raw data by itself does not tell a business what to do. A spreadsheet filled with thousands of rows does not automatically tell us which product is performing best. A database does not automatically tell us why sales have declined. And a collection of numbers does not automatically become a useful business decision. This is where data analysis comes in. A data analyst takes raw information, cleans it, organizes it, analyzes it, and presents it in a way that helps people understand what is happening. In this workshop, we will understand how Excel, SQL, and Power BI can work together as part of that process. We will begin with Excel. Then we will move into SQL and understand how analysts work with data stored inside databases. Finally, we will explore Power BI and learn how data can be transformed into interactive dashboards and business reports. What is data analysis? Before opening any software, let's understand the actual job of a data analyst. Data analysis is the process of examining information to discover useful patterns, trends, relationships, and insights. Imagine that an online store has 10,000 orders. The company may want answers to questions such as, which products generate the most revenue? Which month had the highest sales? Which customers purchase most frequently? Which region is performing best? Which products have declining sales? What is the average order value? How many orders were canceled? These are not simply mathematical questions. They are business questions, and a data analyst uses data to answer them. The general data analysis process can be thought of as a simple flow. First, we collect data. Then we clean the data. After that, we organize and analyze it. Then we visualize the results. Finally, we communicate the findings and recommendations. This means that being a data analyst is not only about knowing software. It is about knowing how to ask the right questions and use data to answer them. Understanding a dataset. Let's imagine we have a sales dataset. Our dataset contains columns such as order ID, order date, customer name, product, category, region, quantity, unit price, discount, revenue, profit. Each row represents one transaction or record. The columns describe different characteristics of that transaction. For example, one row might tell us that a customer purchased 3 units of a particular product from Karachi at a specific price, generating a certain amount of revenue. Now imagine having 10,000 rows like this. Looking at every row manually would be extremely difficult. This is why analysts use tools to identify patterns quickly. And Excel is one of the most accessible places to start. Excel for data analysis. Excel is widely used for organizing, calculating, filtering, and analyzing data. If you are completely new to data analytics, Excel is an excellent starting point because it allows you to understand fundamental analytical concepts without immediately dealing with complex databases. Let's begin with the basics. A spreadsheet contains rows and columns. Rows generally represent individual records. Columns represent attributes or fields. For example, order ID is a field. Customer name is a field. Product is a field. Revenue is a field. Profit is a field. The first thing an analyst should understand is data quality. Before calculating anything, we need to ask, is the data complete? Are there duplicate records? Are dates formatted correctly? Are numbers stored as numbers? Are there missing values? Are there spelling inconsistencies? Are there unnecessary spaces? These issues can affect our analysis. Cleaning data in Excel. Let's say we have a customer column containing Ali Khan, Ali Khan, Ali Khan, with an accidental space. To a person, these may look like the same customer, but depending on how the data is structured, Excel may treat them differently. Data cleaning helps us standardize these values. Excel provides several useful functions for cleaning and manipulating data. For example, the trim function can help remove unnecessary spaces. The clean function can help remove certain non-printing characters. Functions such as left, right, and mid can extract portions of text. Upper, lower, and proper can help standardize text formatting. We can also use find and replace when we need to correct repeated inconsistencies. Another important feature is removing duplicates. Imagine that the same order has accidentally been entered twice. If we calculate total revenue without identifying the duplicate, our result can be incorrect. This shows us an important principle. Good analysis depends on good data. A beautiful dashboard built from incorrect data is still incorrect. Excel formulas every beginner should understand. Now let's talk about calculations. Excel becomes powerful when we start using formulas. One of the simplest functions is sum. We can use sum to calculate total revenue. For example, if our revenue values are stored in a particular range, sum allows us to calculate the total without manually adding every value. Then we have average. Average can help us answer questions such as, what is the average order value? What is the average product price? What is the average profit per transaction? Another useful function is count. Count can help us determine how many numerical entries exist. Counting can count non-empty cells. COUNTIF allows us to count values based on a condition. For example, how many orders came from Karachi? How many orders belong to the electronics category? How many transactions generated profit above a certain amount? We can also use SUMIF and SUMIFs. These become especially useful when we want to calculate totals based on specific conditions. For example, what is the total sales revenue for the electronics category? What is the total revenue generated in Karachi? What is the total profit from a specific product? These functions allow us to move from basic calculations toward actual analysis. If function and logical analysis. Another important Excel function is if. The if function allows us to create logic. For example, suppose we want to classify sales. If revenue is greater than a particular value, we could label the transaction as high value. Otherwise, we could label it as standard. This kind of classification is common in analytics. We can create categories such as high sales, medium sales, low sales, profitable, not profitable, target achieved, target not achieved. This allows analysts to turn raw numbers into meaningful categories. Sorting and filtering. Now let's look at one of the simplest but most useful analytical techniques, filtering. Imagine we have 10,000 sales records. We don't want to look at all 10,000 records every time. Suppose we only want to see sales from Karachi. We can apply a filter. Now suppose we want only electronics products. We can add another filter. We could even filter by sales amount, date, region, or customer. Sorting is also useful. We could sort revenue from highest to lowest. Immediately, we can identify the highest value transactions. We can sort profit from lowest to highest to identify potentially problematic transactions. These simple features can already help answer important business questions. Section 8. Pivot tables. One of the most important Excel tools for data analysis is the pivot table. A pivot table allows us to summarize large amounts of data quickly. Imagine our dataset contains thousands of transactions. We want to know total sales by region. Instead of manually calculating each region, we can create a pivot table. We can place region in the rows area, then place revenue in the values area. Excel can automatically summarize the revenue for each region. Now we might want to analyze sales by category. We can change the pivot table. Now we can see which category generated the highest revenue. We can also analyze sales by month, or product, or customer, or sales representative. This is where Excel starts becoming a genuine analytical tool rather than simply a spreadsheet. Excel charts. Numbers are useful, but visualizations can make patterns easier to understand. Excel allows us to create charts from our data. A column chart can compare sales between categories. A line chart can show sales trends over time. A bar chart can compare regions. A pie or donut chart can show simple proportions when appropriate. But remember something important. Not every chart is useful. The purpose of visualization is not to make a report look attractive. The purpose is to make information easier to understand. If a chart does not help the audience answer a question, it may not be necessary. A good analyst chooses the visualization based on the question. Introduction to SQL. Now let's move from Excel to another important tool, SQL. SQL stands for Structured Query Language. SQL is used to work with data stored in relational databases. Think about a large organization. It may have millions of customer records, millions of transactions, thousands of products, employee records, payments, orders, support tickets. Storing all of this information in one Excel file would not be practical. Databases allow organizations to store and manage large amounts of structured information. SQL gives analysts a way to communicate with those databases. Instead of opening thousands or millions of records manually, we can write queries to retrieve exactly the information we need. Section 11. Understanding tables and databases. A database can contain multiple tables. For example, an e-commerce database could contain customers, orders, products, payments, employees. Each table contains rows and columns. The customers table may contain customer ID, customer name, email, city, country. The orders table may contain order ID, customer ID, order date, product ID, quantity, amount. The product table may contain product ID, product name, category, price. Notice something important. Customer ID and product ID can connect information between tables. This relationship is one of the key ideas behind relational databases. Section 12. Select statement. Let's start with one of the most basic SQL commands. Select allows us to retrieve information from a table. For example, we might want to retrieve customer names, or customer names and cities, or product names and prices. The basic idea is select the information you want from the table you want. This may sound simple, but SQL becomes extremely powerful when we combine commands and conditions. Section 13. Where clause. Suppose we don't want every customer. We only want customers from Karachi. This is where the where clause becomes useful. We can specify a condition. The database then returns only the records that match that condition. We could also filter sales above a particular amount, or orders from a particular date, or products from a specific category. This is similar to filtering in Excel, but SQL is designed to perform these operations efficiently on database systems. Section 14. Order by. Now imagine that we want to see our highest value orders first. We can use order by. This allows us to sort query results. We can sort from lowest to highest, or highest to lowest. For example, if we are analyzing sales, sorting revenue from highest to lowest can immediately help us identify top-performing transactions. Section 15. Aggregate functions in SQL. SQL also provides aggregate functions. These are extremely important for analytics. Sum allows us to calculate totals. AVG calculates averages. Count counts records. Max identifies the maximum value. Imagine a business asks, what is our total revenue? What is our average order value? How many orders did we receive? What was our highest transaction? What was our lowest transaction? These questions can be answered using aggregate functions. Section 16. Group by. Now we reach one of the most important concepts in SQL analytics, group by. Suppose we want total revenue by region. We don't simply want one total. We want separate totals for each region. Group by allows us to organize results into groups. We can group by region, we can group by product category, we can group by month, we can group by customer. This is similar to the concept of a pivot table in Excel. And understanding this connection is useful because the same analytical thinking can be applied across different tools. Section 17. SQL joins. Now let's discuss one of the most important SQL concepts, joins. Remember that our customer information may be stored in one table and order information in another. Suppose we want to know which customers placed orders. How much did each customer spend? Which products were purchased by which customers? To answer these questions, we often need to combine information from multiple tables. This is where joins are used. An inner join returns matching records between tables. A left join allows us to keep all records from the left table while bringing matching information from the right table. Understanding joins is essential for analysts working with relational databases. Section 18. From SQL results to business insights. Let's say we run a SQL query and discover that one region generated significantly more revenue than another. That is a finding. But a data analyst should ask the next question. Why? Maybe the region has more customers. Maybe the average order value is higher. Maybe one product category is especially strong there. Maybe marketing investment is higher. Maybe another region has a distribution problem. This is the difference between simply reporting numbers and analyzing data. A good analyst keeps asking questions. Introduction to Power BI. Now we move to the third major tool in this workshop, Power BI. Power BI is a business intelligence and data visualization platform. It allows us to connect to data sources, transform data, create relationships, build calculations, and create interactive dashboards. Imagine taking our Excel or SQL data and turning it into a professional business dashboard. Instead of giving a manager a spreadsheet with thousands of rows, we can provide a dashboard containing total revenue, total profit, number of orders, top products, sales by region, monthly sales trends, profit trends, customer analysis, and interactive filters. This makes information much easier to explore. Section 20. Connecting data to Power BI. Power BI can connect to different sources. We can connect Excel files, CSV files, databases, SQL Server, cloud data sources, and many other systems. Once the data is imported, we can begin preparing it. This is where another important concept appears, Power Query. Power Query and data transformation. Power Query helps us prepare and transform data. Imagine that our dataset has missing values, incorrect formats, unnecessary columns, duplicate records, inconsistent names, poorly formatted digs. We can use Power Query to clean and transform this information before building our report. We can remove unnecessary columns, rename fields, change data types, split columns, merge columns, remove duplicates, filter records, replace values, and create transformation steps that can be repeated when the data is refreshed. This is extremely useful in real-world reporting. Data relationships. Now let's think about multiple tables. We may have a sales table, a products table, a customers table, a calendar table. Power BI allows us to create relationships between these tables. For example, product ID can connect sales with products. Customer ID can connect sales with customers. A date field can connect sales with a calendar table. These relationships allow Power BI to understand how different pieces of information are connected. This is an important concept because good dashboards are usually built on a well-structured data model. Measures and DAX. Power BI also uses DAX, which stands for Data Analysis Expressions. DAX allows us to create calculations and analytical measures. For example, we can create a measure for total sales. We can create total profit. We can calculate average sales. We can calculate profit margin. We can compare current sales with previous periods. We can create calculations that respond dynamically to filters. This is one of the features that makes Power BI powerful for business intelligence. Building a Power BI dashboard. Now let's imagine we are building a sales dashboard. At the top, we might have KPI cards, total revenue, total profit, total orders, average order value. These immediately provide an overview. Below that, we might have a line chart showing monthly sales. Next, a bar chart showing sales by category. Another chart can show revenue by region. We might also include a table showing top-performing products. And finally, we can add slicers. For example, date, region, category, product. When a user selects a particular region, the dashboard can update the visualizations based on that selection. This turns a static report into an interactive analytical tool. Reading a dashboard like an analyst. Creating a dashboard is only half the job. We also need to know how to interpret it. Imagine our dashboard shows that revenue increased by 20%. That sounds positive. But let's ask, did profit also increase? Did the number of orders increase? Did average order value increase? Was the increase caused by one product? Did one region drive the growth? Did marketing spend also increase? This is why analysts should avoid looking at a single number in isolation. Numbers need context. Practical business scenario. Let's imagine that we are working as a junior data analyst for an online retail company. The company gives us sales data for the last 12 months. Management wants answers to 5 questions. First, what is our total revenue? Second, which products are generating the most revenue? Third, which regions are performing best? Fourth, how has revenue changed over time? Fifth, which products or regions require attention? We begin in Excel. We clean the data, we check for missing values. We remove duplicates. We verify dates in numerical fields. Then we use formulas and pivot tables to explore the dataset. Next, suppose the company stores additional information in a database. We use SQL to retrieve the required records. We use select to retrieve fields, where to filter information, group by to summarize data, aggregate functions to calculate totals and averages, joins to combine related tables. Then we bring the prepared data into Power BI. We create relationships, build measures, create charts, add filters, and develop an interactive dashboard. Now management can explore the information visually. That is the basic workflow of a data analyst. Common mistakes beginners make. Let's discuss some common mistakes. The first mistake is focusing only on software. Knowing Excel functions does not automatically make someone a data analyst. The second mistake is ignoring data cleaning. If the data is incorrect, the analysis can be misleading. The third mistake is creating too many charts. A dashboard filled with 20 different visuals can actually make information harder to understand. The fourth mistake is not understanding the business question. Before analyzing data, ask, what are we trying to find out? The fifth mistake is reporting numbers without explaining them. Instead of saying, sales increased by 15%, a stronger analysis might say, sales increased by 15%, mainly driven by growth in the electronics category. That second statement provides more insight. Skills you need to become a data analyst. If you are interested in building a career in data analytics, technical tools are important, but they are not the whole picture. You should develop several skills: Excel skills, SQL skills, Power BI or another visualization tool, basic statistics, data cleaning, data visualization, problem solving, critical thinking, business understanding, communication. You should also learn how to present your findings. Because in a professional environment, you may have to explain your analysis to someone who does not understand SQL, Excel formulas, or DAX. Your job is not simply to produce numbers. Your job is to make those numbers understandable. Building your data analytics portfolio. One of the best ways to demonstrate your skills is through projects. Instead of only saying, I know Excel, show what you can do. Build a sales analysis project. Create an HR analytics dashboard. Analyze customer behavior. Analyze e-commerce orders. Build a financial dashboard. Analyze marketing campaign performance. For each project, explain, what was the business problem? What data did you use? How did you clean it? What analysis did you perform? What insights did you discover? What recommendations did you make? This turns your learning into something you can demonstrate to employers or clients. Career opportunities. Data analytics skills can be useful across many industries. You may find opportunities as a junior data analyst, business analyst, reporting analyst, BI analyst, operations analyst, marketing analyst, financial analyst, sales analyst. And as you gain experience, you can move toward more advanced roles involving business intelligence, analytics engineering, data science, or specialized analytics. The important thing is to start building practical skills. You don't need to know everything on day one. Start with the fundamentals. Practice regularly. Work with real data sets. Build projects. Learn from mistakes. And gradually increase the complexity of your analysis. Final practical recap. Let's quickly recap what we covered. We started by understanding what data analysis actually means. Then we looked at Excel as a tool for data cleaning, formulas, filtering, pivot tables, and visualization. We introduced SQL and learned how analysts retrieve, filter, summarize, and combine information from databases. Then we moved into Power BI and explored data transformation, relationships, DAX, KPIs, charts, filters, and interactive dashboards. Most importantly, we saw how these tools can work together. Excel can help us explore and prepare data. SQL can help us retrieve and analyze data from databases. Power BI can help us communicate insights through interactive dashboards. Together,
They form a strong foundation for anyone beginning a journey into data analytics. Your next step. If you are new to data analytics, don't feel overwhelmed by the number of tools and concepts. You don't need to master everything immediately. Start with Excel. Understand how data is structured. Learn formulas. Practice pivot tables. Then move into SQL. Learn how databases work. Practice writing queries. Understand filtering, grouping, and joins. Then start building dashboards in Power BI. Connect your data, clean it, create relationships, build measures, design reports, and most importantly, practice answering real business questions. The more problems you solve, the better your analytical thinking becomes. If you found this workshop useful and want to continue developing your skills, this is the perfect time to take the next step. At OMNI Academy, we offer professional learning opportunities designed to help students, professionals, fresh graduates, and career changers develop practical and industry-relevant skills. Workshop participants can also get 20% off on OMNI Academy courses for 7 days after participating in the workshop. So don't stop with today's session. Continue practicing, continue learning, build your projects, improve your skills, and start creating a portfolio that demonstrates what you can actually do with data. For more workshops, courses, career opportunities, and learning updates, stay connected with OMNI Academy. You can also visit our Jobs and Internships portal to explore available opportunities and subscribe to our WhatsApp channels for upcoming workshops, courses, jobs, internships, discounts, and other updates. Thank you for joining our free Data Analyst workshop. Excel, SQL, and Power BI. Keep learning, keep practicing, and keep turning data into decisions.